Okay, welcome back, everyone. I know this one was a hard one, but I'm wondering, did any group complete it? Doesn't matter how you solved it. Did you solve it?
Yes.
Okay, Austin, can we see your group's solution?
Was it Yancey? Was you going to present it?
Yeah, yes.
Did you end up getting the code, or do you want me to just share my screen?
I got the code.
Okay.
I didn't finish the chart. All right, here's the function. So we started with put a variable empty R and just put a
Oh, you're not
empty.
sharing yet.
Yeah.
Oops, my bad. Better?
Yes. Okay, so let's explain it before we T-diagram it.
All right, so we started with to get these numbers, and then input it like this into three different brackets. Started with an empty one to push the new one in, and then we did the AR start sort function to reorder everything. Then we did three for loops. First one I starts at 0, and that brings the first number that we have right here. And the second one goes to I plus 1 is J, and that goes to the second one. And it's same for K. Just keep adding to and third. So it gets the first three numbers and C, and then we bring it back here, and then for if Ri plus J plus K equals target, which is 0. If it equals it, it will and push it into the new array, and it keeps running around until it gets through the whole array, and then that's it.
Okay. So here we have three for loops. One at I, one at J. Now we can T-diagram it. So if we start at I, where are we starting here? 12, right? We get that value 12. And then J equals I plus 1, and var K equals J plus 1. So we have three different values in the array that we're pointing to, all one to the right of each other. And we're running an if statement saying, if these three values together equal the target, then push them to the empty array. And do we get the result when we run it?
New laptop. Wait, all right, here we go.
And there we are. Nicely done. Okay. Does anyone have any questions about Yancey's group's solution? Okay. Well, I'll take that silence for a no. We have no questions about how this works. I think we should skip the T-diagram because we're running low on time. Can we have some other group present a solution that did it differently?
We do have it in a while loop.
Okay, let's see your group solution.
We finally got it working at the end.
Okay.
Am I showing the right one? Yes. Okay. So in the while, we did the same thing as before. We have a empty result, a Boolean check to make sure that we got a result. And then we first have a for loop to iterate through the first variable, which we set to X. Then we declared a variable Y and Z to be the second and third index numbers. And then while the second index number is less than the array length, we will check to see if, first thing we check to see if z is at end of the length, the array. If it is, we will loop back the y, z values to continue through the while loop. After that, we check to see if the three positions, array x, array y, and array z added up together equals the target. If it does, we push that into the empty result. And then we set the result check to true. And then at the end of the while loop, we iterate z. So then when y reaches the end of the array after looping multiple times, it jumps out. And outside of the, so for this for loop, it'll check through all the x positions, and the while loop will check through all the second and third positions after the x. And then we come down here. If the result check is false, which means it didn't find any matches, we'll return there is no results. Otherwise, we'll return the values we pushed into the result.
Okay. So I like what you guys did. You guys took the three nested for loop, you took out the logic, and then you incorporated a while loop within the for loop. And for those wondering why we have a different way of doing this, well, we won't go into teaching this in depth now, but in the JavaScript stack, in the MERN stack, you guys will learn about code efficiency when writing functions, and how three nested for loops make for a really inefficient code. It's a lot of steps to run. It is, we won't talk about notation. There's a dedicated lecture to that. I don't want to confuse everyone here, but John, no, that's not the O notation. So it's a different number. So thank you guys for presenting. And any other group, did any other group do it differently? Okay, I have a different solution. Let me show mine. Okay, it's just slightly different than the last one you saw. Here, I sort the array, and I make the array sorted for a reason. And I create an empty array triplets that I can push to. Then I begin with the for loop. I start the I at 0, and I make I while it's less than array length minus 2. Why minus 2? Or why minus 2? Because we have some other variables that have accounted for that position minus 1 already. Okay, so let's take a look at that. I have a var left, it equals I plus 1. So that's just 1 to the right of I. Okay, we've seen that so far. But now we have a right. A right goes all the way to the end of the array, at the very right of the array. So it starts off in this index. So it would be pointing to that one that has the value of 6 here at the very end. So that is right. We'll call it R for right. Okay, my I is here. Oops, that was a crooked arrow. I is here, and left is here. Okay, and so as I increases, left is going to increase to the right, and I'm saying in this while loop, while left is less than right, because if at any point less is equal to right, then left and right are in the same place, right? If left is equal to right, then left and right are in the same place. So while left is less than right, so while left is to the left of this right index, as we increase I, we have a variable called current sum. Then we call current sum the values at I, the values at left, and the values at right. So we check these three values, and then we ask if it's equal to the target sum. Okay, if it is equal to the target sum, we push these values to this array here, this one. And so if we push, then we increase left, so left moves over one place, and then we decrease right, so right moves over one place. And so it checks the value of, if we make a triplet with I remaining at this place, and then we check I, if we have a match, do we increase left, do we decrease right? If we have another match, then we keep doing that. This while loop keeps checking every possible combination while I is just sitting here at the very first spot. And what we do if we don't have a match is we increase left or decrease right, depending on whether our current sum, which is those three values added together, I, left, and right, if our current sum is less than our target sum, then we know we need to see if we can increase left to increase the value. That's how we're checking if we're getting closer to the target sum by these three triplets. Else, if the current sum is greater than the target sum, then we decrease right. We move right to the left, which is going to give us a smaller number in this sorted order. That's why I introduced it. That's why I introduced this sort array, because we can sort an array and decrease left or right. We know that if we increase left, we're going to get a higher value, or if we decrease right, we're going to get a lower value in that sorted array. Okay, so you guys can digest this solution. I'll post it in GitHub, and you guys have your own. So I'm proud that you guys found a great way to solve it besides the way that I showed you here. Okay, but now you have this way, it's efficient. So take a look at this in addition to your answer. Sometimes a more simplified answer makes sense after you worked through the solution yourself, trying to find your own answer. A simplified answer, you can appreciate it more after you worked on it yourself. Okay, so let's continue on with our day. Do we have any questions before I close that out? Sorry if you did. You have any questions about this, how this works? Anybody? Okay. I'll take that silence as a no. Let's continue on with our day. We have to do our daily stand-ups after this, and we're also going to introduce the concept of UX, UI. Okay, so let's take a break, and then we'll start our lecture.